Good morning, Year 4, and welcome to today's maths lesson. As you can see, we are carrying on with our equivalent fractions, and what we're doing now is probably putting together the bits of the jigsaw that you've already been working out the past few days. And don't worry, actually, you know what, today it's a pretty straightforward lesson, and it's just going to make sure we're at the right point, and then we can move on to what we're doing in the next few days and weeks. Okay, so before we get started, let's get ready, and some questions for you to be having a go with at home. Pause the video now and go and do it. Okay, so first question says, what equivalent fractions can you see in the bar models? Okay, well, I'm going to look at the one with the fewest parts first. I can see that this one here is broken up into thirds, and the top one is broken up into, count them, 9 equal parts, so ninths. Okay, so we've got ninths there, and we've got thirds there. Okay, what equivalent fractions can we see in there then? Well, if I was to shade in that much, that would be 3 ninths and 1/3. So 3 ninths is equivalent to or equal to 1/3. If I shaded in all of this, I've got 1, 2, 3, 4, 5, 6. 6 ninths is equivalent to 2/3. All the way across, I'd have 9 ninths is equivalent to 3/3. Okay. On to the second one. It says to use the number line to find the equivalent fractions. Now, this is what we looked at yesterday, isn't it? On the top, you can see that it's broken up into fifths. There are 5 equal parts. 1, 2, 3, 4, 5. There's 3/5. On the bottom, split up into 15ths. And you can see there that within these fifths, each one is split up into 3. There's 3, another 3, another 3, another 3, and another 3. 5 lots of 3, 15. So 3/5 is there. How many 15ths is that? Well, you know what? I could count 1, 2, 3, 4, 5, but it's not efficient. What I would do is, I know that each of these is 3 lots of 15. So I'm going to have 3/15ths, 6/15ths, 9/15ths. Okay, I could have counted them 1, 2, 3, 4, 5, 6, 7, 8, 9, but I think that's more efficient. 15/15ths we know is all the way at the end because it's the same as a whole. When the numerator is the same as the denominator, it's one whole. Okay, so 15/15ths would be the same as how many fifths? The numerator would have to equal the denominator, so it'd be 5/5. Remember, numerator equals denominator equal is one whole. Okay, let's get on with some learning for today. Okay, so some bar models. I'm going to split them in half, so I'm showing halves. Going to use a bar model of the same size now and split that into quarters. How many quarters is going to be equivalent to my half? You can see that there is going to be 2 quarters. If I get the next one and split that into 1, 2, 3, 4, 5, 6, 6 equal parts into sixths, you can see there that if I was finding what was equivalent to a half, I'd have 3/6. On the bottom one there, you can see I've got 8 equal parts, so I split them into eighths. And if I was shading in a half, I've shaded in 4/8. 1/2, 2 quarters, 3/6, 4/8. Those are my equivalent fractions on there. I wonder if you can see a pattern between the numerators and the denominators, year 4. What patterns can you see? Now, tell you what I can see. I can see that the numerators is going up in ones. 1, 2, 3, 4. Could keep going. The twos is going up in, the denominators, gave it away, is going up in twos. 2, 4, 6, 8. So maybe this isn't all of them. Maybe this is just the ones that we've got on the screen. Maybe we could continue that on. Maybe you also notice that the numerator is half of the denominator for these fractions, because these were equivalent to a half, remember. So 1 is half of 2, 2 is half of 4, 3 is half of 6, 4 is half of 8. What would the next one in that sequence be? What would the next equivalent fraction in that sequence be? Perhaps you can scribble it down on your paper and show me when you do your portfolio submission. Now, here we have a fraction wall. Now, fraction walls that we have up in the classroom are really, really helpful for finding equivalent fractions. Okay, so at the top, we call the one across the top one whole. And we have a half, a third, a quarter, a fifth, 6, 7, 8, 9, 10, 11, 12s. Okay, normally they stop at about 12, but obviously we can have smaller fractions as well. Have you noticed what happens with the fractions though? As the denominator is getting greater, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. As the denominator number gets greater, what actually happens to the size of the fraction? Hopefully you noticed that with this fraction wall that as the denominator gets bigger, the actual fraction is getting smaller each time. Because what's happening is that one whole at the top is being split up into more and more and more equal parts each time. Well, there's always so much you can break up. If I had half of this paper, okay, that would be greater than having a quarter of this paper. There's half the paper, and there's a quarter. Well, I know which one is smaller. A quarter is smaller than a half. So perhaps we can start making some generalizations about as the denominator gets greater, the fraction gets smaller. Okay? Now, like I said, fraction walls like this are really handy for working out equivalent fractions. Okay, so if I said 5/6, for example, I wanted to find some equivalent fractions for 5/6. What I do is I find my 6, there they are, the yellow row in the middle, and I'd find 5 of them. Okay, and what I do is I go to the end of the fifth one, where the interval marker is at the end of the fifth one, you can see it there, and I'd look up and down my fraction wall for anything else which is exactly the same mark. So on the fifths, you can see this one, it's not at the same point. On the sevenths, this one isn't at the same. But if I was to draw a line down, I can see that, at the bottom, I've got some 12ths that match up. How many 12ths? There we go. We've got 10 12ths. So 5/6 is equivalent to 10 12ths. Let me repeat how we did that again. I've got 5/6, so I'm going to find my 6 here. I've got 1, 2, 3, 4, 5. I'm then going to draw a line across my fraction wall in a perfectly vertical line, going straight down or up. I'm going to see if there's any other bricks on the wall that match at that point, and I can see down here on the 12s that it goes through perfectly. This one on the 11s almost goes through, but it's not perfect. It needs to be absolutely bang on. If it's not perfect, it's not equivalent. Okay, and there was 10 12s. Now, here's some fractions. 2/5, 2/3, and 6/8. Can you have a think and find as many equivalent fractions on that fraction wall as you can for those? Pause the video and have a go and give you a clue. There may be more than one answer for some of them. Off you go. Okay then, year 4. So 2/5 we started with. So what we're going to do, we're going to find our fifths and we're going to highlight 2 of them. And I'm going to look for any fractions that finish at the same point as this line here. So let's drop that line down. And I can see on the tenths there, I've got some there. And how many tenths is it? It's 4/10. And you can see there's no other lines on the fraction wall where that red line goes through. So I found all of them on the fraction wall. There are others, but obviously it's with fractions that aren't on the wall. It's with ones that where the denominator is greater than 12, so 13ths, 14ths, 15ths, etc. Let's look at 2/3 now. Finding thirds, I need to go up here to my thirds, and I need 2 of them. And then I'm going to drop my line down, and you can see, got some here. How many sixths is 2/3? It's 4/6. Okay, but hang on, there's more. Dun dun dun. If I go down, you can see that it also goes through one of them, which is on the 9ths. How many 9ths is there? 1, 2, 3, 4, 5, 6 9ths. Hang on a second. There's another one. Go down to the bottom where there's 12ths. You can see how many 12ths I've got there. I've got 8 12ths. Now, I've got to the bottom of my wall, so I know there's no more on the wall, but like I said, doesn't mean that there aren't smaller versions of fractions that could also be equivalent. Can you spot a pattern with those? In that family of 2/3, that fraction chain there. Ooh, I wonder. If you do notice a pattern, Year 4, write a little note on your work, and I'll read it when you do your submissions. Last one is 6 8. So let's go down to our 8s, the purple one here, and let's get 6 of them up. And let's draw our red line. Okay. Now, I can see there that it goes down through 12ths, and there are 9 of them. How did I count that so quickly? Well, I counted the ones that are at the end. If I know there's 12 altogether, and there's 1, 2, 3 missing, I know that what's missing must be 9 12ths. That's it. Found them all. But no, I haven't. I've not found them all because that red line is only going down. Did anyone check if it was going up? Ah, there is another one. Sneaky little quarters hiding away up there. How many quarters are there that's equivalent to 6 8ths? It's 3 quarters. That red line can go up and down, Year 4. Okay, so just be careful of that with those that you may have to find on your tasks today. And that's it. Like I said at the start, it's a very straightforward session, finding the equivalent fractions using that fraction rule. Have a go, Year 4. Like I said, this is sort of like our first checkpoint with our fractions. We'll get past this and then we'll move on to other things later in the week and then next week when you're back at school. Okay, Year 4? Great effort today. Can't wait to see what you find with your fraction rules. Have fun.